Okay, section 7.2, multiplying and dividing radicals. So here's an example of what it might look like if we are multiplying two radical expressions together. Of course, the a, b, and the n would represent letters or variables. But we can only multiply radicals when their index is the same, if they're both square roots, if they're both cube roots, etc. So as long as the index is the same, we're going to keep the index out front. Then all we need to do is multiply the numbers and or the variables that are underneath, and that would result in AB. So again, to multiply, they must be the same root. You're just going to multiply the numbers. If there's variables, you just add the exponents of the variables. Then you simplify from there. Dividing is very similar. You cannot divide radicals unless their index is the same, and we're going to keep the index. And then we just divide the two radicands, or whatever is underneath each of the radicals, a divided by b. So the roots must be the same. We'll divide the numbers. Since we're dividing variables, that's when you subtract the exponents of those variables, and then simplify after that if you need to. And then the other thing we're going to do in this section is called rationalizing the denominator. So it's considered incorrect or not simplified if you leave a radical in the denominator of an expression, like 1 over the square root of x. It's not simplified all the way. So the way to rationalize the denominator, or to simplify that, is to multiply the bottom of the equation by that radical, whatever will make it cancel. And you know, whatever you do to the bottom of a fraction, you have to do to the top of a fraction. So I would do 1 times the square root of x, which is just the square root of x. On the denominator, the square root of x times the square root of x is the square root of x squared, since we're adding those exponents. Then I would simplify. The top is just going to be the square root of x. On the bottom, when you take a square root of a square, that cancels, and you're just left with an x on the bottom. So the more you do this, the more you'll get used to it, and you'll start to see a pattern. So the rule is multiply the top and bottom by whatever will make the radical on the bottom simplify. So if it's a square root, you got to make it something that will be squared underneath the radical. If it's a cube root, you got to make it so that whatever is underneath will be cubed. Fourth root, make it so that it will be to the fourth. Whatever will make that radical go away is what you want to multiply the top and bottom by. Okay, so let's look at some examples. We're going to start with multiplication. So I have the square root of 8 times the square root of 32. So since they're both square roots, I can multiply the numbers that are underneath the radical, 8 times 32. So 8 times 32 is 256. Now I just need to simplify 256 like we did before. So I'm going to factor 256 and start with a prime number. So I'm going to do 2 into 256 128 times, then 2 into 128 64 times, 2 into 64 32 times, 2 into 32 16 times, 2 into 16 8 times, and 2 into 4, or 2 into 8 goes 4 times, and then 2 times 2. So once it's all factored out, everything on the outside should be prime numbers. Since this is a square root, I'm looking for pairs of numbers. So you circle all your pairs. Well, it turns out for 256, I have no leftovers, so I'm going to multiply each of these pairs together. So there's 4 pairs, so that's going to be 4 2s. 2 times 2 times 2 times 2, which is 16. And you may have even had memorized that the square root of 256 is 16. It's a perfect square. Okay, now let's try one with variables. So I have the cubed root of 8y to the 5th times the cubed root of 40y squared. So because they have the same index, they're both cube roots, I can multiply underneath the radical. So it's the cube root of 8y to the 5th times 40y squared. So I'll multiply the numbers, 8 times 40, and then add the exponents of the variables. So that's going to be 320y to the 7th. Now I can simplify. So I'll factor 320. 2 goes into 320 160 times. 2 into 160 80 times, 2 into 80 40, 2 and 20, 2 and 10, 2 and 5. So it's completely factored. Since this is a cube root, I'm looking for sets of 3. So I circle my sets of 3, and I actually have a leftover on this one. So those groups of 2 will come outside of the radical, but that 5 is going to have to stay inside. So that's 2 times 2 on the outside, and the cubed root of 5 on the inside for the numbers. Now we look at the variable. So remember, 3 goes into 7 how many times evenly and how many remaining? 3 goes into 7 2 times evenly with 1 remaining. So the 2 pairs get to come outside, the 1 remainder has to stay inside. So now we're just going to simplify. 2 times 2 is 4, y squared, times the cube root of 5y. I can't do anything else to simplify this. Okay, so now we're going to look at division. So we start with the square root of 10x squared y to the 5th divided by the square root of 5xy squared. So since they're both square roots, I can divide everything out first and then try to simplify. So I can write it inside if you need to, or if you don't need to do this step, you could jump to the next step if you want to. But I'm going to divide the numbers, 10 divided by 5. Then I will subtract the exponents of the x's, subtract the exponents of the y's. Okay, so I know that 10 divided by 5 is 2. X squared over x simplifies to just x because 2 minus 1 is x to the first. Y to the 5th over y squared reduces to y cubed. Now I can take the square root. So I'm going to see square root, I can't take the square root of 2. Does 2 go into the 1 exponent for the x? 2 doesn't go into 1, so my x is going to stay inside also. Then 2 into 3 goes 1 time evenly with 1 remainder. So this just simplifies to y times the square root of 2xy. Okay, so now we have another one, the square root of 48x cubed over the square root of 3xy squared. So we're going to start by dividing, or you can rewrite them on top of each other inside. And we want to divide these out. So let's start with the numbers. 48 divided by 3 is 16. I have an x cubed over x, which will be x squared. There are no y's on the top, so I can't divide them with any y's that are on the bottom. So that y squared is going to have to stay on the bottom. Now I can take the square root of the top and the square root of the bottom. The square root of 16 I know is 4. The square root of x squared is just x. And then on the bottom, the square root of y squared will be y. So this just simplifies to 4x over y. Okay, now we're going to look at rationalizing the denominator. So this just simply means that once you've done everything you can in a problem, we can't leave a square root in the denominator. So if this happens, make sure you follow these steps. So if I have something like the square root of x over the square root of 2, I can't do anything to simplify the square root of x or the square root of 2. They're simple as they can get by themselves. And x over 2 doesn't reduce as a fraction. So I can't leave that square root on the bottom, so I'm going to multiply the top and bottom times whatever will make that square root of 2 simplify or cancel out the square root. So since it's a square root, I just need to multiply by the square root of 2. Because it's a square root, I just need a pair of 2's. So whatever you do to the bottom, you have to do to the top. So let's multiply. On the top, the square root of x times the square root of 2 is just going to be the square root of 2x. On the bottom, square root of 2 times square root of 2 is the square root of 4. Now we simplify. The top can't be simplified. Square root of 2 doesn't simplify. The square root of x doesn't simplify. So that's just the square root of 2x on the top. Now on the bottom, the square root of 4 we know is 2. So that just simplifies to 2. So instead of square root of x over square root of 2, that is equal to square root of 2x over 2. No radical in the denominator. Okay, let's try a cube root. So the cubed root of 5 over 3x. Okay, so I can't leave, if I wanted to, I could go ahead and separate this and say the cubed root of 5 over the cubed root of 3x, but that's just an extra step that I don't need to take here. I know that I can't take the cube root of 3x. That isn't going to simplify because there's not triples of anything within 3x. So I have to multiply top and bottom of this fraction by whatever will make the cubed root of 3x cancel. So since it's a cube root, I need 3 3's, and I would need 3 x's. I already have 1 3 and 1 x, so I'm going to multiply by what I don't have, which would be 2 more 3's and 2 more x's. So 3 cubed, or 3 squared, and x squared. So I need to multiply top and bottom times the cubed root of 3 squared x squared. So on the top, you just multiply the numbers underneath the radical. Okay, so on the top, I'm going to multiply 5 times 3 squared x squared. So 5 times 3 squared is 5 times 9, which was going to be the cubed root of 45x squared. Okay, now for the bottom. 3x times 3 squared x squared is going to give you the cubed root of 3 cubed x cubed, which is what I wanted on the bottom so that that cube root will cancel out. So the top, if I factor 45, I know that it's 5 times 3 times 3. There's no triples in there, so I can't simplify the cubed root of 45. And for the x squared, 3 doesn't go into 2, so I can't simplify x squared either. So the top is just going to be the cubed root of 45x squared. And then the bottom, because those are both cubed, they're just going to come out of the radical. I could factor them out, but that would just be an extra step. So on the bottom, it's just going to simplify to 3x. I wanted that radical to go away. So the cubed root of 45x squared all over 3x. Okay, now the last one. I've got 15 times the square root of 60x to the 5th over 3 times the square root of 12x. So before I get carried away to rationalize the denominator and to simplify that radical on the bottom, let's see if we can divide and make it simpler first. So 15 divided by 5 I know is 5, or 15 divided by 3 is 5, so that reduces. Now underneath the radical, because these are both square roots, I can divide under it as well. 60 divided by 12 is 5. And then for the x's, x to the 5th over x reduces to x to the 4th. So everything on the denominator actually canceled out on this one because I divided first. Now I want to see if I can simplify this. So I've got 5 times the square root of 5x to the 4th. So the 5 outside is going to stay. The 5 inside is going to stay because I can't take a square root of 5, but I can simplify x to the 4th. X to the 4th, or the square root of x to the 4th, is x squared. So that x squared comes outside. So my answer is going to be 5x squared times the square root of 5.